Fats are the most misunderstood of the three macronutrients, and the truth is that there is a lot to know before we can make confident and informed decisions about how we incorporate fats into our diets. But a good place to start is understanding what saturation means, because we very often hear saturated fats versus unsaturated fats. It's important to know what that means. To say that a fatty acid is saturated is to say that it is saturated with hydrogen atoms, or that molecule is holding on to as many hydrogen atoms as it possibly can. An unsaturated fat is different because it is not holding on to as many hydrogen atoms as it possibly can, but instead has a different chemical structure, and that different chemical structure results in much different physical properties when we use these oils in real life. Now, all fats are susceptible to something called oxidation, and if vulnerable fats are exposed to too much light, oxygen, and heat, they oxidize and produce free radicals. Okay, now this oxidation breaks down susceptible oils into many different components called free radicals that can produce toxic and sometimes unknown effects on the body. At that point, the oil becomes rancid. It smells very bad, and it's full of free radicals, which we don't want to consume. Saturated fats have certain physical properties, and they can be described as relatively stable and inactive molecules. They are slow to react with other chemicals, carry no electric charge, and tend to aggregate or combine, which is why we find them in solid form at room temperature. They are simple, sluggish, and uninteresting molecules, but they are the most resistant to oxidation. So that means that they can be exposed to the most amount of light, oxygen, and heat before they begin to alter their chemical structure, oxidize, or produce free radicals. Unsaturated fats also have certain physical properties, but they can be described as less stable and more chemically active. They carry negative charges and they repel one another, preferring to disperse or move apart rather than combine, which is why we generally find them in liquid form at room temperature. But the more unsaturated a fat is, the more susceptible it is to oxidization, and the more likely it is that exposure to light, oxygen, and heat is going to accelerate that process. The next thing we should do and realize is that saturated fats like butter, clarified butter, coconut oil, lard, beef tallow, etc., these fats are best used for cooking and exposing to high heat because they are the most resistant and most likely to maintain their chemical structure. Unsaturated fats like olive oil, peanut oil, different vegetable oils, and fish oils are the kinds of oils that should be well protected from light, oxygen, and heat because they are the most susceptible to oxidization. This also means that they're not suitable for cooking, but they can be used to dress salads and condiments. Knowing your fats and their appropriate uses is an absolute game changer. Their differing physical properties dictate their use, and if you can understand that and correctly apply that to your diet, you're going to be so far ahead.